Our goal today is to look at every crater on Earth that resulted in meteorites that we can have in our collection. We are looking at something that very, very few people on Earth have a collection of.
You betcha.
Hello, everyone, and welcome. It is the 27th of July, 2022. We're here for our 115th in a row Knowledge Bolide Weekly Hangout, sponsored by Topherspin Meteorites. And I really want to thank the crew and everyone on YouTube for putting up with us the last few weeks. Our schedule's been a lot out of control, but we told you we get to the crater creators, and that's exactly what we're doing today. We even have a special introduction to the topic. Does our crew member Allison want to introduce us to this week's topic?
Yeah, I'm excited. We're talking about meteorites that have created craters. That's a rather rare event on Earth, thanks to our atmosphere. Over 10,000 meteorites can enter our atmosphere on any given day, but most of those are very small and traveling so fast that they burn up before they hit the Earth. If they do hit the Earth, they're most likely dust or pea-sized pebbles. Of those, maybe 17 or fewer in a day are fist size or larger that do actually land on Earth. Hopefully they don't land in the ocean or somewhere that we can't obtain them. So a meteorite landing on Earth is a rather rare event. But NASA says that approximately every 2,000 years, give or take, a meteorite hits with enough force to create a crater or to disrupt the Earth's crust. So I think that's fascinating, and the crew is going to help us all learn a lot more about meteorites that created craters.
That's awesome. Thank you very much. I think when we were doing the research to this, and Mike Kelly is going to have his 101 later, so we're going to really deep dive into the crater formers for meteorites. Now, he's going to get into this, but there are 190 plus craters on the Earth that are named and known. We don't care about all of them. We only care about the ones we can collect meteorites from. So that's what we're going to be focusing on today. I really want to thank the Knowledge Bolide crew and my wife, Sue, for helping me put this show together today. I've been a little under the weather, and I really needed the support of my crew and my wife, and I got it. So thank you very much. We're going to just jump right into the show and tell. We're going to keep a quick pace to this show. So we have our own resident Iron Man in the house, Mr. Ron Metchis.
Iron Man, huh?
Yeah.
Okay. So in my collection is mostly irons, probably 95% are irons. Okay, and of those, I have 133 pieces. Of those, I have 9 crater creators. I'm going to show 4 of those today. So the first one we're going to get to is a Morasko. It's from Poland. Let me share the camera.
We actually had to ask Ron to limit what he was offering on show and tell today. He had so many of the really cool crater creators. So this first one's Morasko.
Yeah, this is Morasko. It is from Poland, posed on Poland. It was found in 1914. It's an iron. This one happens to be about 759 grams, although I see some rust on it. I haven't looked at this thing in a long time. It's a coarse octahedrite. It's a type IAB MG, main group. I do have a picture of the crater here I'd like to share.
Yes.
So basically it looks like a scum-covered pond to me. But this is the crater that was formed. So
could you imagine walking around in the woods and walking upon that without realizing it?
I mean, look how perfectly round it is.
Yeah. Oh, it's amazing.
Yeah. So this one was again 1914. I want to jump from this one to the Hickman. This is by Hickman, and I just recently got this. This is an Australian meteorite. I actually have a picture of the crater here. Let me share that real quick.
Nice. Yeah, everyone gets bonus points during show and tell if you can show the crater as well.
Okay.
Yes.
Oh.
Okay, that's the Hickman crater, and I think I have a second picture of it here. Yeah, that's it right there. That's more a ground level view. This is kind of an aerial view. So the ground level view I think is a little bit better. It's kind of hard to recognize as a crater. To me, it looks like a cattle tank, frankly.
Yeah.
It's not that big. It's from Newman, Western Australia. It was found June 2018. This particular piece is 165 grams. It's a medium octahedrite, IAB group. There we go. So this little guy, it's not very big. You can see my hands in there, but it's actually a very pretty piece.
That's got a pretty patina on it.
Is that an iron?
Yeah, it's an iron. These are all irons.
Okay.
It's an Australian meteorite, and it's got the typical red clay color that you would see on
Yep.
like a Boxhole or something like, which I'm going to show later, by the way. So this is two of the crater creators that I have in my collection.
That's fantastic. So we have
Nice.
Poland and Australia so far in the house.
Yeah.
We're gonna jump to Carl
Yes.
and Diane. Carl has two that I don't have, and Diane's gonna show one I don't have. So we're very interested in this.
Okay.
Okay.
All right, Carl, I have your pictures loaded. Please tell us what we're looking at, man.
Hey, these are a couple more Australians since we're talking about those down under. This is Dalgaranga crater. This is in Western Australia. It's about 75 kilometers northwest of Mount Magnet in Western Australia. This is at the time, this is the smallest, if not one of the smallest in Australia craters and the world. And it's also one of the oldest intact superficial craters on Earth outside of Antarctica at 270,000 plus years old. This was formed by a Mesocytorite A to be exact. And several people studied this crater. Even it was discovered back in 1921, and several people had checked it out. But in 1959, Harvey Neininger and Glenn Huss went down there and collected some samples and meteorites and stuff from the crater and brought it back. And the piece I have is from Harvey Neininger through Glenn Huss, from Glenn Huss to New England Meteoritical to me.
Wow. And this
I
is
am the
piece
third
right here?
owner of this piece.
This
is a piece of very weathered Dalgaranga from the Neininger collection. And this came from that crater, collected by him. It's only about a gram, maybe slightly over a gram. But just the provenance of it is what's so cool about it to me.
Yeah, absolutely. And it seems to be a very weathered Mesocytorite.
It is.
Right?
He in his paper that he wrote in 1960, he mentions how weathered a lot of things were. And he also, it's quite humorous story. I'm not going to go into that, but you can look it up.
Mm-hmm.
They had quite a time on their adventure down there, and it's pretty entertaining reading.
Nice. I'm going to ask you guys as we go through our show and tells, if you see anything or know anything about the protection of these craters, it might be a good side subject to hit on.
I believe that this one has now got a sign on it saying this is a crater site. So as far as I'm aware, in Australia, they're very keen on protecting their craters.
It does look like it's a protected site.
Yes,
like
it is.
These signs right here. Awesome. Okay.
This is Veevers crater, which is near the Gibson Desert in central Western Australia. It's also not a very large crater. The Veevers crater was originally discovered in 1975 by geologists. So they decided to name it after a guy named John Veevers, who was a fairly well-known geologist in Australia who was working in that area back in the 1950s. Now, in the 1980s, 1984, Carol and Eugene Shoemaker went down there and studied this crater and found the iron meteorites around it and confirmed its status as a crater. They wrote a paper in 1985 or 95 called The Metallography and Thermomechanical Treatment of the Veevers 2AB Crater Forming Meteorite. This is a 1.1 gram piece of that I believe was brought back by the Shoemakers. This has also got provenance through New England Meteoritical back to them. It is a only crater on Earth known to be formed by a Type 2AB meteorite.
That's very cool.
And that's just a polished slice there. It's not etched, it's just polished.
Yeah.
So there's only 300 grams total known weight of this meteorite.
Wow. That's crazy. See, that's what drives me wild when I see and know what we're doing. We're looking at, our goal today is to look at every crater on Earth that resulted in meteorites that we can have in our collection.
Yeah.
So to have this one is pretty cool for only 300 grams total weight. So Thank you very much, Carl. I really
You're
appreciate
very
it.
welcome, Topher. It's great fun, man.
All right, Diane, what is this mud puddle we made us look at?
What you're looking at here is the Carancas crater in the Puno region of Peru. The meteorite fell September 15th, 2007 at 12:45 in the morning. Its impact and explosion were the first impact event recorded by modern seismic equipment. And it was only the second confirmed witnessed fall crater after Sikhote-Alin. And it's probably, well, as far as I have been able to find, it is one of two craters on Earth that has yielded stony meteorites rather
nice.
than irons.
Okay.
The other one is a huge crater in South Africa that the core samples found meteoric material, you know. So I found that a very interesting one.
Yes. Yeah.
But
So this is actually Carancas
yes,
right here.
Carancas.
Carancas. Now, this is your sample here. Do you know the weight of it?
Our sample is about 0.2 of a gram.
Nice.
So it's
And-
just a little piece
Yeah.
that's seen under my microscope. But there's a good story with this one. You know, as I say,
that's what I was.
it was
You're
a
about to
witnessed
answer my
fall.
question. Go
It
for it.
was, you know, as I say, it was a witnessed fall. It hit right next to the small village of Carancas. You know, so they see this bolide come roaring in and boom, blasted out a 98-foot diameter crater, 20 feet deep. The blast wave knocked a guy off his bicycle and threw debris all over the village. There wasn't any major injuries or damage. And the braver of the villagers said what just happened and came to investigate and saw that the crater was filling up with bubbling groundwater, which they later described as boiling groundwater, and it was giving off steam that smelled like rotten eggs. And they told researchers who arrived to investigate about this, and when a bunch of the villagers fell sick afterwards with headaches, digestive problems, and skin irritations, you know, they had to go in for medical treatment, and people are saying, what in the world made these people get sick? This has never happened with a meteorite before. And there's still a mystery with that. The question hasn't fully been resolved. It's thought that since the groundwater has arsenic in it, that the fumes of arsenic in the steam may have done some of that. But it's also been proposed that troilite from the meteorite vaporized and produced some hydrogen sulfide.
Wow.
And those symptoms are certainly consistent with hydrogen sulfide poisoning.
Wow. Carancas is definitely a unique one, a crater maker that made people sick. It has cool history to it. And also, as Diane hinted, it is one of the few non-irons to create a hole on our Earth.
That's cool.
We have definitely had some metal iron meteorites to cause substantial craters here on Earth. So we're going to move to Chris Monkman, and he's going to talk about two American irons that cause craters. So Chris, you with us, buddy?
Yes, I am. So I'm going to bring us back to the United States. And of the two I'm going to show, this is the first one. This is Odessa. Odessa is in Texas. And in Texas, there is a 165-meter wide hole. Right now, it's only 2 meters deep, but originally, I think it was something like 30 meters deep. This is an individual, it's about 188 grams. This is actually one of the first irons I bought. I think it was the second iron I bought. But a real cool thing is once you look inside of these.
Oh, yeah.
Oh, yeah.
There is some wicked cool patterns and silicates and, you know, graphite inclusions.
Ooh.
Nice.
This is actually aesthetically, as far as an etched piece, this is one of my favorite. It reminds me of the movie Tron.
You're dating yourself.
I know, I'm old.
Nice
But-
slice.
That is a beautiful slice of Odessa, man.
That is.
A really cool part, I'd like to get on Google Maps and look at images of the craters and stuff like that. When you get on Google Maps, you look and it looks like an entire strewn field just of craters. And an interesting point is, well, this landed on a big limestone, I don't know what the word is, but like
Plateau.
Yeah, like a limestone plateau. And so there's a bunch of basically sinkholes,
Right.
that are perfectly around and, look like craters. This side is not etched or polished, but that look like craters. So, I mean, and they're all in a row and it looks like the direction of the fall. So I always thought that was very interesting. There is the single main crater, and then there's 4 other little small ones real close to it. But yeah, it's all the holes around it are just limestone sinkholes.
Oh, that makes up the Permian Basin in Texas. That's
That is
cool.
a really cool slice, Chris.
And then
Wow.
Oh,
I have.
Wow.
I'm going to bring it to my home state of Arizona.
wow.
This is a 180 gram slice of everybody's favorite Canyon Diablo.
Mhm.
Nice.
That's a gorgeous piece.
That is
Ooh, that
that is
nodule on that one.
yeah. That is an A
Several
plus
nodules.
plus quality one, man.
Yeah, this right here is why I bought this piece.
Oh yeah.
Wow.
It just grabs your attention and takes you to town.
Yeah, huge graphite inclusion, man.
Yeah.
Nice.
And I'm sure everybody, I'm not going to talk too deep about Canyon Diablo, but in northern Arizona, there is a very huge crater. If it's not on your bucket list, it should be.
Mhm.
But there's a huge crater that you should go see, Meteor crater, Barringer crater. And yeah, it's definitely a sight to behold.
Yeah, I'm super glad that you're showing and talking about Barringer crater and Canyon Diablo meteorite, because those on YouTube right now watching this are looking at pictures of when I organized a trip to Meteor crater. Thank you. Yeah, so some of the pictures you're seeing now are from that trip, and you can see the grandeur and size of the what's left, the major hole in the ground that you can't miss. And I asked to do my show and tell directly after Chris, because I wanted to see his beautiful slice, just so hopefully our X-ray vision can take over and we can kind of guess what's inside my individual. But I can't be a meteorite collector, live in Arizona, and not have a showstopper for me of a Canyon Diablo. But this is 2 kilos of Arizona love.
Yeah.
That's beautiful.
Oh, that's a nice one.
Nicely done.
Oh,
Oh,
Talk
look
about
at that.
inclusions.
Great.
there's a nodule.
Great shape.
Very nice.
It's
Wow.
got a beautiful shape to it. It's not just a nugget or a big oversized nugget. It's got some really good shape to it. You can see there was probably some graphite inclusions or something that fell out there. It's got
That's
a tiny
sculptural.
bit of the natural patina that you get with built up caliche.
Mhm.
Nice.
Man, that's a beautiful, shapely piece.
Yeah, thank you very much. This is when Chris said that's why he bought that slice. Well, this is one of the deciding factors of why I bought this one.
Yep.
Yeah, for
One-
sure. You could put some water in that and throw some guppies in there and have a little pond.
So if I ever slice it, which I won't, the first slice will be right here. But this is my showpiece this is my really great Canyon Diablo that I've been wanting for a while. Now I'm going to keep it in America and show a meteorite that also made a crater.
Oh,
And lo and behold, it's not a iron, but it does have a lot of metal in it. This one created a crater. Unfortunately, the crater is not named similar to the meteorite. So this created Haviland crater Does anyone know the meteorite I'm holding?
That's beautiful, Brenham.
Brenham.
There you have it.
Brenham, Kansas.
Correct. Wow, the crew is on point today.
And that crater was originally described as a buffalo wallow.
Yes.
Well, Zoom is not letting me zoom in on my cell phone, but I wanted to highlight the etch on it because as you can see right here,
Yeah.
that is just a beautiful, beautiful etch, and it follows the contour, in the metal. But this is a really nice piece here where it's etched. There's not a whole lot of halicites that I know of that created craters here on Earth. So this is a Brenham, not Brahin. Brahin is from Europe, but this is Brenham. So
Beautiful.
Yeah, it's a nice piece
Yeah.
of it.
yeah, I really, really love this one. And well, I love this meteorite. This slice is for sale. So, well, yeah, there's certain pieces that will never be for sale, at least in my mind right now. Like this will never be for sale. It's mine. I love it, and the ability to replace that without spending 6 months looking, I just don't want to do. Well, we have a lot more show and tell, and we're, like I said, we're keeping the pedal on the gas today. I hope you guys don't mind us just tearing through and getting as much bang for your buck as possible. But we're going to move into our patent pending copyright Meteorite 101 with Mike Kelly. Mike, 101, craters, take it.
Yep. So craters 101. So on the left, you got meteorite crater. It's kind of interesting because it's not round, it's a square. That's because it's called a jointed crater. It's a jointed crater, which means that it hit an area that already had joints in the ground that are 90 degrees to each other. So as the crater expanded and went out, it ran into those joints and it itself squared off. So it's a kind of a unique crater for Earth because there are not too many square craters on Earth. Looking over on the right-hand side, that's the south end of Mars. That's where the solar system's largest crater is. It's called Utopia Basin, and it's that big blue circle in the upper right-hand corner of that quadrant.
Oh, cool.
Yeah, right up in here.
Yep.
Very cool.
So craters. So it's any depression on the surface of any body, be it a moon or a planet. And it could be any size, really, by definition, from a microscopic crater all the way up to hundreds of kilometers across. I do believe the biggest one in the solar system is on the order of like 3,000 kilometers across. That's what we just saw on Mars. There's another type of structure called an astrobleem, and sometimes you'll hear those terms used interchangeably. But basically, what an astrobleem is a very old crater where the majority of the structure has been eroded away. And you just have subsurface features left. So what you see over on the right-hand side is called Panther Mountain in New York. And it's kind of actually an inverted crater. So the center of what used to be the crater is now the top of a mountain. And you see that creek running around in an almost perfect circle around it. Creeks don't run in circles usually. So that's actually following the old eroded away rim of where the crater was. So there's very large features of craters, which would be obviously the rim, which is the elevated circle around it. The walls are the interior of the crater as it's slumping down. And a lot of times those are really steep. And because they're so steep, a lot of times they'll settle out and they'll do what's called slumping. So sometimes when they slump like that, you'll actually get rings within the craters as they step themselves down. And you have the crater floor, which is the flat bottom of the crater where a bunch of material falls back in or gets eroded back in. And then what happens is a lot of times with the craters, as the meteorite impacts, the force of the impact pushes the ground down and out, but the down and out motion eventually rebounds and comes back and in. So in a lot of the larger craters, what you'll have is called a central uplift or central peak. And that's a little hill or mountain in the middle of the crater from that rebound function.
Wow. I'm sorry, Mike. We've seen a bunch of those on the moon when we were looking at astrophotography. Is that the same creation of like a drop in milk where it has that rebound effect in the middle?
Exactly. Yep. It's a drop of water pushing back up. And then the final term I have on here is the ejecta, which is the blanket of material that gets thrown out of the crater physically by the force of the impact. And so that ejecta spreads out around the exterior of the crater, and it forms a blanket called the ejecta blanket, which is usually thickest going at the edge of the rim and then thins out as it moves further away. And on a lot of craters, like you mentioned, we talked about the moon. A lot of craters on the moon have rays. There are actually craters on Earth that do have rays, and that's a kind of a function of a differential amount of material being thrown in different directions as it goes out of the crater. Usually on the craters on Earth, what happens is that gets kind of washed away by erosion or other weathering functions. So it disappears real quickly on Earth, where it's preserved on other asteroids and planet bodies that don't have as much active weathering going on.
Very cool.
Small features. So these are very definitive, right? We've seen lots of craters in the past, and there was always a question on whether or not it was caused by a meteorite or it's a volcanic crater, or like Chris Monk was mentioning, could be a sinkhole. So these are some of the features at a very small level that give us key indicators that it's not any of those other causes. It actually is caused by a meteorite. So shatter cones are a unique compression feature in the rock underlaying the crater. And they make little cones, what they call horsetails, that point back towards the point of impact. And it takes a lot of pressure to make them, like 2 to 30 gigapascals to make them. And so you don't get that sort of force in anything else but a meteorite impact. The other interesting thing on there is the images you see to the right are the mineral coesite, and that's a high pressure form of quartz. And again, the pressure it takes to crush and make that quartz is something you don't get in a volcano or anywhere else. So that's indicative of being a meteorite crater. And then you also get things like the bottom shot there, which is called planar deformation fractures. So inside bits of quartz, you'll see parallel to the shock wave going out through the ground. The quartz actually gets all shattered up inside the individual crystals, and you get those planes that form. And you can see them in that shot there. And finally, I'll talk diaplectic glass. This is a weird thing. So you can make glass 2 ways. You can make glass by a lot of heat, which is how we make all of our glass. When you're talking Coke bottles and such. There's a second way to make glass, though, and it's very rare, and that's by making it with shear shock pressure alone. So instead of bringing the temperature up, you just bring the shock wave through, and it basically destroys all the crystal structure, and it turns minerals into glass. And so one we talk about a lot is mescalinite, like in the sugartites, which is clear glass that's been made from basically shocking plagioclase to the point that it just turns to a glass. Well, the same thing happens in these impact craters. You'll get earth-formed shock glasses where it wasn't caused by melting, it was caused by compression.
That is so cool. You promised to teach me what diaplectic glass was, so thank you.
And that's what it is. Yep. So talked about this a little bit already. You got small craters and large craters. Again, a small crater as simple as less than 2 kilometers in size. If you're hitting something like sand or soft sediments, and it's considered to be less than 4 kilometers in size if you run into something hard like bedrock. And then you get the complex craters, which are these bigger, huger craters with these central uplift rings inside of them instead of a single peak. And they're kind of divided up into craters, basins, and ring basins. So again, that kind of implies a certain amount of size, and it transitions between, below 10 kilometers up to 50 kilometers, and then much bigger than 50 kilometers. And so the image I have here is a picture of Valhalla Basin from Callisto. And if you look at that crater, it basically takes up that whole image. And you can count like 10 or 11 different structural rings in there. So that's a very large ring basin. And again, what happened was, as that crater was made and the crater walls were really steep, it slumped in circular patterns and kind of created benchmarks, and flat areas moving towards the center of the crater. So again, that's a ginormous 2 kilometer wide crater.
Wow.
Over on that.
I'm glad you explained it, because I had no idea what that was when I was building the slides.
Yeah, it's just showing you how many rings something can get when it has the chance to be a very, very large crater. So we talk about meteorites being relatively new science. Well, crater formed by meteorite is even newer than that. It didn't really catch on any steam until 1903, when Barringer procured his crater and started saying that it was of cosmic origin and created by a meteorite. that didn't really get proven out till 1960s when we already talked about Gene Shoemaker, who helped out with some of the craters down in Australia. He did his PhD on the dynamics of crater formation at Barringer, and they had a mineral coesite that had been made in a lab but had never been found out in nature before. And he was the first person to find it. And the first place he ever found it, Meteorite crater.
Very
So
cool.
Meteorite crater is the type locality for coesite, which is that high pressure polymorph that you can only make by impacting with a meteorite to get those sort of pressures. So after that, in the 1960s, 1970s till today, it was a rush to find all these craters around the world. So we hit a bunch of these craters already. We're gonna hit the rest of them. One clarification: there's 3 stony meteorite craters, and I'll talk about the last one on there. Kunya-Urgench is also a stony meteorite that formed a crater. So there's 3 of those. We mentioned that the rest are all irons or pallasites or mesositerites, and Diane hit it on the head. You know, they last better than chondrites last. So even though there are 190 craters out there, there's only these few with meteorites associated with them,
Mike,
because those are the meteorites that lasted. Go ahead,
Mike,
Dover.
the top lines there says 190 of these craters are in the EID. We looked it up, but can you tell the crew what the EID is?
Certainly, yeah. It's called the Earth Impact Database. So it's kind of like the Met Bowl, but for craters.
All right, thanks.
Yep. Yeah, no problem. And then I got a couple asterisks on there because like Kunya-Urgench is not in the EID, but it is in the Met Bowl, and I added that one. We talked some really cool things about a bunch of these craters, like Morasko, that Ron had mentioned is actually, it's multiple craters. So that's kind of cool. It's like a crater strewn field. Same thing that that Chris had mentioned with Odessa is, you know, several of these have multiple craters all linked together. So these are all of the craters that have a meteorite associated with them by cross-checking the EID against the Met Bowl.
What's cool about this is I have 10 out of the 19 of those.
Wow.
What Mike, one's missing, and we talked about that yesterday.
Yeah, and you bring a good point. Yeah, so there is an Agadal crater and there is an Agadal meteorite, and the Agadal meteorite is not associated with the Agadal crater. Yeah, the
I thought it was all this time.
Yep, the Agadal crater is very old, and the Agadal meteorite, you know, they do terrestrial exposure testing to see how long it's been there, and it's been there nowhere near as long as the crater has been there. So it's literally just a meteorite fall that happened to land in a crater.
That is so cool, man. Well, Mike, I'm going to ask the question to the crew. What do we feel about Mike taking time out of his busy schedule week in and week out to craft these wonderful Meteorite 101 lessons for us?
Mike is my hero.
Super good stuff, Michael. Super good
Superb.
stuff.
Thank you.
Super.
These are great. They're so
Awesome.
informative.
I
I
feel
love
smarter
doing
than
every one of them. So
Very informative, Mike.
Big round of applause.
Yeah,
Oh, yeah.
Yeah.
yeah. Thank you so much. These hangouts don't build themselves. It takes a lot of work and a lot of effort and a lot of team to build them. And Mike has been our 101 assistant and staff geologist. And we're just really appreciative to have you on our team, buddy. Thank you very much.
Awesome.
Definitely.
Love those one-on-one mics. Thanks so much, man. We're going to slide right into some more show and tell. We're going to go north of the border this time with Smiley. Smiley, how are you?
Doing good. How are you doing, Topher?
Very well, bud.
Good to hear.
You
Good to
had
hear.
you had a Whitecourt you wanted to show us, one from your home country.
What I'd like to do first is show off the actual crater itself here. So it's just basically it's a depression that, you know, going by, you'd never notice anything special about it. Kind of blends in with all the other kind of hills and scenery. But it wasn't until, again, some metal fragments and shrapnel were being discovered that, again, it was kind of identified that there was actually a crater here. And you were speaking earlier with regards to signs that are posted. So this is the one that's posted at the crater site itself. So There are large finds in the province of Alberta with regards to craters. As far as meteorites themselves, this crater is considered a heritage site. So anywhere around 200 meters, you find a meteorite within that area, it's against the law. Again, you can see the fines there. It's 50,000 Canadian or 1 year imprisonment. Outside of that, you're free to collect. Again, laws in Canada, or if it falls on private property, it's the owner who you need to talk to as far as either purchasing from or coming up with a deal with. So again, like I say, this is a sign that's posted there. If you switch over to Smiley Cam, what I kind of wanted to do is show when you're collecting meteorites out at this by this crater, what you actually come across.
Smiley Cam is live.
So when you're first collecting fragments of this meteorite, the soil is very clay. So literally when you're running over the metal detector, you get a clay lump. So this is like a 34-gram clay lump, right? So it's like kind of like collecting eggs or nuggets. So it's like Easter all over again, right? So you're going to wash it off, clean it up. And what's cool is I'm not going to show a big meteorite this time. What I'm going to do is I'm going to show a really cool meteorite. So this is a 23-gram shrapnel piece of Whitecourt. So again, this is the kind of stuff that you can find in these clay nuggets, as I call them. And like, they're really gnarly, lots of shrapnel sections, very sharp.
Yeah.
Nice.
Very,
nice.
very interesting, right?
Yeah.
So it's cool. And yeah, it's fun going out there and like I say, collecting these clay nuggets and then coming across stuff like this. Because every once in a while you come across one of these that have nice sharp edges. So
Very nice.
It's cool.
And
Very
this hunt
cool.
is done with metal detectors?
You betcha. Yeah. So the largest piece that I got in my collection that I've showed on previous shows, that one was actually gnarled in a bunch of tree roots. So again, most of it's been picked over already, but people are going out with fancier and fancier metal detectors that can detect even deeper, and they're finding some of the missed stuff, so to speak. So
good for them.
But yeah, it's cool.
Wow. So do you think that inside that clay one there are small meteorites or one big meteorite in there fragment?
That one will just be one. So actually,
because to be honest with you, this is new for me.
Yeah. So like, for instance, like this is a couple examples here. So like I say, they're just clay balls, and you wash them up. And so the larger the meteorite, the larger the clay ball, right? So again, it depends on the time of year you're collecting. In this case, this was kind of in the springtime, so everything was soupy and whatnot. So yeah, it's cool. It's cool.
Very cool. The idea of not knowing but knowing what's inside would drive me bat crazy.
Yeah, like I say,
has been scratched.
Exactly. So then the next thing I wanted to show here. So this meteorite here, it's iron 3AB. Sorry, an iron 1AB from the main group. It's a Campo de Cielo. This piece here holds a special piece in my collection because it's actually the second piece in my collection. The first piece I actually bought for my dad when I went out to Meteorite Crater there, or Barringer Crater. And this was my official second ever meteorite purchase. So this is a 275-gram piece. And what I love with it is the fact that it's got that kind of sculpture type look with the fissures and it displays really nice, right? So
it's
absolutely love it.
I've ever seen.
Nice display piece.
Yeah,
and it's stood up really well. Before I really got serious into meteorite collecting, it sat on the shelf, and for close to 6 years, never rusted. Very, very stable. That being said, when I got really serious in meteorite collection, it got shoved in my collection cases with everything else, with my dryerite and all that kind of good stuff, just to preserve it, right? But yeah, it's a special piece to me because, like I say, it's the second piece, and yeah, it's a good chunk. I like it.
That's beautiful, man.
Yeah.
Great
Very
shape to it.
nice.
And I'm going to put you on the spot. Could you also show us the picture that you have to go with the crater?
You betcha. So,
because this is the crater show, and this created craters in Argentina.
A crater that you can visit or a protected crater? Does anybody know?
So I'm not sure.
They're still hunting around it and finding newer ones like Campo.
Yes.
Some gigantic ones. Yeah.
Yeah. Some of the biggest ones on Earth.
No, they're illegal to take out of there now.
Oh, okay.
Yes, they are. That is correct. Yeah. In fact, I believe Richard Haig was prosecuted.
Bob
Sorry,
Hayes.
what was it? Rob Haig.
Bob
Yes.
Haig.
Yeah. He was prosecuted for trying to take out of the country this meteorite. So
if you see something, say something. Come on and party tonight.
But what's cool with this is, reading up on it, is the fact that it's a strewn field of meteorite craters. So there's about 26 meteorite craters in according to Wikipedia, 1.9 by 11.5 mile strewn field pattern. But again, to Topher's point, they're still locating and identifying chunks. So I'm sure the crater count's still going up on this one. But again, it's neat to think that, again, we think of strewn fields as being, smaller fragments, right? But to consider and think, like we've discussed with Odessa and whatnot, the fact that there's crater strewn fields as well. So it's neat. It's very neat.
Yeah.
It's a huge fall.
Absolutely massive.
Tons and tons and tons.
Yeah.
Appreciate you showing those too, and showing us pictures of the craters too. So you get extra points for pictures of the craters.
Sounds good.
Our 101 guy wants to show off it too. So let's give Mike a chance at some show and tell, guys.
All right.
Oh yeah.
All right, how's everyone doing? I'm gonna
Very
switch
well,
around.
man.
So usually I don't do too much show and tell because I do the 101, but I wanted to make sure we got all of the available crater hitters in there. So I signed up for a couple that I saw weren't on the list for anybody else. So let me flip the video and we'll do this.
Okay.
The most common meteorite that everyone has in their collection, Sikhote-Alin, is in fact a crater former. So this produced a 27-meter diameter crater, which a lot of people don't realize that was a crater forming event. So common meteorite, everyone has it. This is 110 grams of shrapnel. So nothing too fancy there.
Oh, but I like the rollover lips on top.
Yeah,
it's got roll going on the shrapnel, getting folded over all over the place. So that's the everyday common crater. Another one I wanted to highlight is Warbar. So Warbar is in Saudi Arabia, and it's another one of the irons. But what's neat about this was they mounted an expedition in 1932, and it was one Harry Philby who went out there because he was told there was a lost city of Warbar out there. It was kind of the Sodom and Gomorrah story where the king was destroyed for his sins and the whole city was destroyed. But it was said that there was a camel-sized piece of iron out there in this ruined city, and he went to go find it. Of course, he found no ruined city, but he did find a crater structure with the Warbar crater and the Warbar iron, and they found a whole bunch of different fused glass type materials around there, including Warbar pearls, which the assistants to this expedition collected up hundreds and hundreds and hundreds of these Warbar pearls and brought them back, thinking that they would sell them on the market, that they were real pearls, only to be told that they were not real pearls, and so they got rid of them all. Which is a huge tragedy because nowadays those are really hard to find, along with bits of metal from Warbar that aren't oxidized.
I was going to say, Mike, for those that don't know what we're looking at, we are looking at something that very, very few people on Earth have a collection of.
Yeah, so this is everything you can own from Waybar. It was a sandy crater, so there's the sand. There were splash form bits of glass that were thrown out of that crater. The bottom sand was fused, and some of it wasn't melted too much, and kept its kind of white sandy texture. Other bits were fused completely and turned a dark black. There's a fair amount of oxidized bits of metal out of that crater, and just a little bit of unoxidized metal on the market along with the pearls. So yeah, that's a full kit of Waybar.
That
Nice.
is
Sweet.
amazing. Yeah,
Nice.
as soon as we announced or had the idea of the creator formers, I was like, hey, you're showing your Waybar. That's an awesome collection. Thank you so much for taking us through that.
No problem. We mentioned a third stony meteorite that's crater former. So this is Kunya-Urgench.
Yep.
This is that third stone, and the impressive thing about this, although my piece is small and unimpressive, is this is one of the top 5 largest falls in the world.
Mhm.
And so the main mass is like 900 kilograms. It landed in a field like some 60 meters away from a bunch of individuals. It was very well witnessed, and produced a very large dirt crater. So there's that one. Kaalijarv is a crater on an island, and the kind of neat thing about this one is there's a very decent written proof in some runes that potentially this was a witnessed meteorite, and has led to some mythological aspects in the Finnish mythologies.
Oh, cool.
Because Kali basically is said to be the place where the sun goes to sleep.
Uh-huh.
So it
Very
it
cool.
formed a crater lake, and it's been a sacred spot for a very long time over there. And they think that there's some origins in that the creation of that crater lake with the mythology. And finally, one last one, finishing off on Australia. This is Wolfe Creek. So that's spelled Wolfe for the crater, because it is named after a gentleman named Wolfe. And it is a early studied crater as far as being found back in like the 60s or 70s. And the kind of only interesting fact I had on this one is it was the site location for 2 horror movies, also called Wolfe Creek, but spelled WOLF. I've yet to try watching them, but who knows?
Yeah, I recommend the Meteorite, not the movie.
So
Wow.
that's all I had. Hopefully that gets us through, and we should be able to see all of the craters but 2 of them.
Nice.
Yeah, very
That's
nice.
amazing. That's the
That's
power
cool.
of the knowledge Bolide crews to get weird oddballs like that not very many other people have. So thank you, Mike. There's no other video on YouTube. You have to go to a museum special exposition for just crater former meteorites in order to see all of them like we're showing today.
Mhm.
I know, we were off. No pun intended.
Well,
Yeah.
We're sticking in Australia, and we have our Iron Man Ron.
Boxhole is an Australian iron. It is from the Plenty River, Northern Territory of Australia. The age of the fall is estimated to be between 5,400 plus or minus 1,500 years. So this piece is it's 185 grams, and it's a medium octahedrite in the 3AB classification. So this is kind of a cool one. This has got the typical red patina you would find on an Australian meteorite. Hopefully, okay. Are you seeing this?
Oh
Yeah, nice patina.
Okay, yeah,
Good.
Ours is somewhere up here.
true. Okay, yeah. So this is another one. I do have about 9 Australian meteorites. I made a video specializing in Australian meteorites. So if you like it, I'll put it on your website. You can use it for your.
Oh, that'd be awesome.
Might be a good topic just for one of your hangouts.
Yeah, I was going to say there's so many Australian meteorites and
I know.
Australian craters.
It's amazing how many there are, and they're so well preserved because it's such a dry place.
Yeah.
Right.
Okay, so let me go from this one. Oh, let me show the crater real quick.
There we go.
Okay, yeah,
Uh-huh.
that is the crater. It's kind of hard to see, but there was definitely a crater there, believe it or not.
Yeah.
Yep.
Okay. And
Is that
this is the
is
only
the middle line of the screen? Is that the far wall of the crater, Ron?
I believe so, yes.
Okay. Okay.
So this is a fully sculpted
Oh,
Henbury.
Very nice.
It is the most beautiful meteorite I've ever seen, short of being a Sikhote-Alin.
wow.
That's cool.
Nice piece, man.
That's really nice.
I saw this, man. I jumped on this thing fast. You could say Henbury crater.
Yep.
Nice.
Wow. That is the show side right there for me. Holy
Yeah, it
crap,
is.
that's beautiful.
This is the
Wow.
So let me
Classic,
get a couple of,
classic.
okay, this one in particular is 226 grams. It's a medium octahedrite, again at 3AB. And this is from the Northern Territory in Australia. The age of the fall is estimated to be less than 4,700 years. And it was found in 1931. But it's just a gorgeous, gorgeous piece. I'm going to
Yeah,
go
it
back to
is.
the camera.
You want an interesting Henbury fact, Ron?
Sure.
Yes, we do.
So the Aboriginals in that area have a legend that the crater was formed during a fiery explosion, and they call it Chindu China Waru Chingi Yabu, which
Oh my.
translates roughly to Sun Walk Fire Devil Rock. So there's a good chance, like you
That
said,
is a mouthful.
it's a mouthful, but it also kind of alludes to the fact that it was probably a witnessed fall.
Yeah.
Yeah,
Yeah.
that's
Yeah.
what I think.
Wow.
That's awesome.
But I mean, short from being a Sikhote-Alin, this is one of the most red molybdate and sculpted meteorites I have in my collection.
Yeah, you're making me realize
nice.
how much my collection is missing a Henbury. For those watching on YouTube, if you have an idea for a show, why don't you drop it in the comments? I read and reply to every single comment, no matter how long it takes me, no matter how many people ask me to identify their rock or how they can send me pictures. No. I want to finish off show and tell with my iron, and it's an iron that you can identify just on sight alone. Some of the irons that we've talked about today, like I've seen some posts on Facebook where a Canyon Diablo, a Gibeon, and a Boxhole were all thrown around as possible names to identify this meteorite. There's no mistaking this one. Okay, so this is the one that I don't think many people will confuse.
Oh, Gebel Kamil.
Gebel Kamil.
Yes.
Very
So-
nice.
Wow, that's a nice piece.
And everyone's gonna say it a different way.
Yeah.
It's got the lizard skin on the outside. It's very distinct.
Yeah.
Very
You
nice,
can actually
nice hunk.
see- You can actually see the earth line right here, where this part was in the ground, and that was sticking up along with that. So that's how it was in the ground. Move my thumb right about there. And you're right, it does have that lizard skin texture to it. This is not Australian. You got me saying Australian. This is an Egyptian iron.
What's that weigh, Topher?
About that much.
Yeah, it's
I
about
don't know, 240 grams ish, something like that, quarter kilo.
Nice piece.
Yeah. If you want to call it Gebel Kamil, you can. If you want to call it Gebel Kamil, that is the correct pronunciation.
I've seen it spelled differently too.
Yeah, there's a lot of people who spell it incorrectly. I've learned by putting videos on YouTube, I want the meteorite name to be spelled correctly. This is how it's spelled correctly.
Mhm.
Gebel Kamil from Egypt. It's an ungrouped, but yeah, it's one of those that you can instantly identify based on just its look, its color, its texture, everything. I think that was the last item on the show and tell. We do have a question from YouTube viewers, and to introduce that question, we have Allison. Allison, are you with us?
Yeah. This week's YouTube viewer question for our in-house honorary Professor Pat.
Mhm.
Is there any seasonal meteor shower that produces more meteorites than other meteor showers?
Well, that's kind of a trick question, because none of them produce meteorites. So meteor showers are associated with periodic comets. So there's a number of comets like Halley's Comet that we see periodically, and they're in an orbit around the sun in a very eccentric orbit. And when they come in close, comets are basically dirty snowballs. There was a fellow named Dr. Fred Whipple who proposed that in 1950, and turns out he's right. So they're carbon dioxide ices, water ice, methane ice, etc., with some crumbly dirt sort of stuff on them. And as they go around the sun, when they get close to the sun, those ices sublimate and expand, and they shed little particles. Key is little. And so they create a tube of these particles in their orbit around the sun many, many times. And these periodic meteor showers, the paths of those comets that we hit on our orbit around the sun result in seeing meteors. The ones that you see that just go and there's no light or anything, just no trail, no nothing, they just come and go, that's smaller than a grain of sand. The ones that go and leave a little white line for a little bit and then fade, that's a grain of sand size. And these things are considerably larger than grains of sand. So the comet or the meteor showers are wonderful visual events, but they don't create meteorites. And through history, there have never been any meteorites associated with meteor showers. And there, I did it in 2 minutes.
Thank you so much. And I want to add to that.
record.
Thank you, Allison, and thank you, Honorary Professor Pat. And I want to add to that, because we know where that tube of debris is, and we know where the Earth is going to be. That's why they're predictable. That's how we can say on August 3rd, look east, because that's the side of the Earth that's going to be smacking into this debris tail. That is not true with meteorites. As Pat said, they're a lot larger, they're more chaotic. They were bounced off of something and headed here by themselves or with maybe a few little brothers, but that's it. It's not a cloud that we're going to be flying through as a planet. So thank you very much for that explanation. All right, guys, that was a great episode. Thanks a lot.
Good night, everybody.
Good night.